Scaling MySQL. In this final nugget of the course, we'll take on two subjects that are near and dear to the heart of many MySQL administrators, frankly because they're just so useful. The first of those topics is multi-server MySQL. And what this topic means is, how do we functionally get more than one installation or instance of MySQL running on a single piece of hardware? The second topic is one that we've discussed in periphery throughout the course many times, but here we're actually going to learn how it works functionally, and that is the topic of replication. Without further ado, let's get started. First, we have some preliminary definitions on scaling. Oftentimes in the IT industry, we have the distinction between scaling up our network infrastructure versus scaling out. I want to make sure as we proceed through this nugget that you and I both understand our terms correctly. Now, when we refer to scaling up a MySQL server, we're referring to, of course, vertical movement conceptually, and practically we're referring to adding hardware to that server to boost its capabilities and performance. Now, in the previous several nuggets, we've talked about scaling up a MySQL server in terms of adding hardware in 4 chief subsystems. And to review, those 4 chief subsystems have been memory, primarily physical memory such as RAM, and virtual memory, which is tied to the second of those 4 subsystems, the disk subsystem. Third, we have the processor or CPU subsystem, and then finally, the network subsystem. So that's scaling up, where we're adding hardware to our server to boost capabilities and performance. Now, when we talk about scaling out a MySQL server and a server infrastructure, there we draw the line horizontally, and this deals with the R word, redundancy. We're building out redundant servers for the purpose of fault tolerance as well as performance, but really primarily scale-outs are done for fault tolerance. Fault tolerance is essentially a synonym for redundancy, isn't it? This is where we're going to use, for instance, replication to bring up multiple instances of a MySQL server such that if one machine were to go down catastrophically, unexpectedly, or maybe expectedly for planned off time, maybe a hardware upgrade if we were doing some scaling up, we could still have our services available for our users, for our customers, and so on. All right? There are other mechanisms to scale out an infrastructure. Of course, there's server clustering. That's beyond our scope right now. Bottom line is I just want to make sure that we're really clear on that distinction between scaling up and scaling out. Multi-server MySQL. When we speak of multi-server MySQL, we're referring to hosting 2 or more instances of MySQL server on one physical or virtual server computer. And if you're new to MySQL, this idea may not seem all that useful to you. You might think to yourself, well, why would I want to do that? I mean, didn't you say, Tim, earlier that your best practice is to have a dedicated machine to MySQL? I've got a rack, a 1U or a 2U server, and that's going to be my MySQL server. I'm going to have one installation of MySQL Enterprise or MySQL Community Server, and that's all she wrote. Well, yeah, that's all well and good. However, what happens in the real world isn't always as cut and dry in that. There's many cases where you may have requirements, business requirements that call for hosting more than one installation or instance of MySQL server. I can give you a few of those directly off the top of my head. One is a hosting environment. Think of an internet service provider or simply a service hosting provider. You don't even have to be a full-fledged ISP, where you are providing web application or web hosting for your clients and customers. And on your server, you are providing each customer with their own dedicated or virtually dedicated instance of MySQL server. For some of my own private web hosting, I use GoDaddy like many people do. And of course, with them, you will get your own quote-unquote private MySQL server instance. where you can create up to X number of databases. Now, certainly, a Joe or Jane customer is not going to have their own dedicated GoDaddy server. You're using one of their boxes. Chances are you're using a virtual server on one of their physical boxes, along with who knows how many other customers. So certainly their infrastructure is involving many simultaneously installed instances of MySQL Server. Now then, in your business environment, you may be testing multiple versions of MySQL Server. Maybe you're considering an upgrade to MySQL Server 5.4. You're currently running 5.1 and you want to test your line of business application moving forward to take advantage of MySQL 5.4. This would necessitate having a side-by-side installation of those two versions on your server. A third case, not quite so common, but depending upon the smallness of your shop and how much money, how little money you have to work, you may have a development and production instance on the same piece of hardware. That's certainly not recommended. But the list goes on. The situations that may come up in which you have more than one instance of MySQL Server installed on the same machine. The bottom line, the overarching thing to remember for your exam and for your real-world success as a MySQL DBA, your goal is you want to make sure that each instance does not collide with any other instance installed on that box. Basically, each instance needs to be an island unto itself. You want each instance of MySQL Server to exist in its own separate box. Each instance of MySQL needs to have its own data dir, its own log files, its own base dir, its own installation directory. On Windows, you want your service names to be different. For instance, MySQL, MySQL1. You want your my.ini or my.cnf option files to be completely different. Each service will call its own option file. And this is really important here. Your network interfaces need to be different. Remember that by default, MySQL Server is going to listen on TCP port 3306. If you have two installations of MySQL running on a single box, you're going to have to create two separate sockets. One, maybe the first installation will listen on TCP 3306 at the IP address 10.0.0.1. Second installation, maybe you can keep it on 3306, but maybe you'll have to install a second IP address on a second network interface card at 10.0.0.2. You see what I mean? In other words, you have to do everything possible to ensure that your two instances or any additional instances you have do not conflict. Another case, if you have just a single network interface card and you're going to maintain the same IP address, in that case, you could have one instance listening for connections on TCP 3306, and you could have the second instance listening on the same IP address, but maybe choose 3310 instead of port 3306. Now, I'm just giving you the bare bones guidelines here on this whiteboard. We don't need to go into deep details on the subject for the exam. For detailed instructions, because the specific instructions for setting up a multi-server MySQL rollout are going to depend, of course, a lot on your host operating system, whether you're on Unix or Windows. You're going to want to check out the MySQL reference manual. There's an article there. It's kind of a parent article that has some sub-articles to it. It's called Running Multiple MySQL Servers on the Same Machine. That's going to be your go-to resource, and frankly, in my experience, you'll even want to go beyond the reference guide and hit up Google as well. It's that kind of a deal. Not that difficult as long as you just keep this as your main goal, making sure that your separate installations of MySQL are fully separated. Now let's turn to the second half of this last nugget, and this deals with MySQL replication. Replication provides a really handy way to extend a MySQL database infrastructure. You can solve a lot of problems by instituting replication. Now, if you come from another database management system, such as, say, Microsoft SQL Server, at first blush you may be disappointed by some perceived limitations in MySQL's replication architecture. For instance, out of the box, in particular what we're looking at in this nugget is just a one-way replication architecture, such that you've got one read-write master server that has the master copy of the database to be replicated, and multiple replication partners denoted as slaves that are going to have just read-only copies where you cannot make updates. Now that's very different from most other RDBMSs, again, particularly the Microsoft SQL Server variety, where you have all sorts of two-way transactional replication schemes to choose from. Now don't be dissuaded. You can do two-way replication in MySQL. It's simply beyond the scope of the exam objectives. We're just looking at your baseline one-way master-slave replication scheme here, so stick with me. Now, what are some advantages to this replication scheme? I've given you the major ones down here at the bottom. First of all, let me just back up, and for those of you that are brand new to this subject, replication, if we look at the word, the root is replica, and a replica is meant to be an exact duplicate of something. You might have, say, a replica of Darth Vader's mask from the original Star Wars movie. Of course, it's not the mask that David Prowse wore during the filming of Star Wars, but it's sized exactly the same, made of, say, the same materials, looks exactly the same, feels exactly the same, but it's not the genuine artifact. In MySQL database terms, what we have here is a source database that we need to bring, for whatever reason, closer to another user population. Maybe we have too much resource contention over here on this side of the house. Maybe we have a gang of business analysts who need to hit the database to generate reports and pretty pictures for their bosses and the marketing team or who knows whom, and we're generating too many locks and just contentions over here. So we need to create a copy of the database in another location. Maybe this other location is not just another floor in a single office building, but is in another geographic location in the same state or in a different state or in a different country. So we have the issue of low-speed connectivity, a wide area networking link. Now there's a really good use for replication, where you've got really difficult connectivity, and we can bridge that gap by taking a copy of that source database and then bridging the divide. And here you're really making the data much, much easier to get to for users in the case of a low-speed wide area link. So that's this third point down here. Replication eases or reduces and potentially eliminates data contention or competition to get to database resources, and also makes it easier to bring data closer to users. By making a copy of data, we can bring that data closer to users. These business analysts can gnaw at the copied data. Unfortunately, as I said earlier, the replicated data is read-only. You can select against it all day long, but you're unable by default to make changes to it. When you're reporting against the data, all you need to do is select anyway, so it's not a big deal. Just as importantly, though, we have these first 2 points. Replication can be very helpful for fault tolerance and disaster recovery purposes. Again, when we scale out, we're breaking out a resource, in this case a database, and creating copies of it such that if something were to happen catastrophically to part or all of our master resource, if this database were to go corrupt, if the entire server were to be destroyed in a fire or tornado or who knows what could happen, ideally, because any update, and I mean any, a single update statement that happens to master is going to go across this replication channel and update these slaves so they're absolutely current transaction by transaction. If we lose the master, then we can, in theory and in practice, reinstate either of these slaves as a new master server. You see? So therefore, there's honestly and truly a fault tolerance and a disaster recovery solution happening in a replication architecture. Now, earlier in the course, when we spent a lot of time talking about MySQL log files, I mentioned that one advantage of the binary log is that it can be used in a fault tolerance disaster recovery situation. As a nutshell review, the binary log is that log that can be optionally enabled. It's not enabled by default. And the only kind of SQL statements that the binary log records are change statements. Let me use the mathematical statement of the delta. So it will log updates, deletes, and inserts. It won't log selects. And as we're going to see for the remainder of this nugget and in the upcoming and final demo, guess what log is used in a replication architecture? You got it, the binary log, such that whenever a change SQL statement, like an update, a delete, or an insert happens on the master, that change is recorded on the binary log on the master, and that's actually what triggers the replication event that is then producing the mirrored change on your slaves. Pretty interesting fact, isn't it? At this point, leading up to the demo in which I'm actually going to walk through replication configuration, let's look at those statements and explain them here so we get an idea on how replication's configured in MySQL Server. It's pretty basic, actually, and we've covered a lot of the commands and places where the stuff is configured. So at this point, this is really serving as a nice capstone for the course. All right, first thing we're going to do is look at master server configuration. Now remember, I'll draw this off to the side. We've got our master server that contains the read-write database that's going to be replicated, and then we have our slave server that's going to have the read-only copy of the database, okay? So that's our conceptual picture over here. I'll keep that off to the side. First thing we're going to want to do on the master server is create a user for the slave. All right, now this is creating a MySQL user. In a sense, it's kind of a MySQL service account. Remember, when we deal with inter-server communications, we always have to think in terms of credentialing. When we have one MySQL server communicating with another one, there's always the question of user account authentication and how is that server going to authenticate itself to the other server. So what we need to do on master is create a user for the slave. So what this statement is showing is we're creating a user named slave, and we're specifying the host name of the slave server here, slave at MySQL slave or MySQL slave, identified by, and then we're providing a password, and we're being really granular with our passwords here, and there's a reason for this. We're granting the replication slave permission. This is granting only the permission that's necessary for this user. Remember the security principle of least privilege. We want to grant only enough privilege for this user to get the job done. And we're granting that permission on, at least in the sample code, all databases, all objects. But you want to be granular here to grant these permissions only on the database objects that you want to replicate. For instance, if you're replicating world, you might want to specify world.star. And you're replicating these to, in this case, of course, slave at MySQL slave. The thing you want to be aware of here is that this credential, the user and password, are going to be stored in plain text in the master.info configuration file. Now, earlier in the course, when we talked about file system security, I talked about setting permissions, file system permissions, to make sure that unauthorized parties cannot read file system objects. Well, this is going to be a file system object on your server. And just know that master.info is going to store the username and password of your slave user. So that's another reason why you want to create a dedicated user for this replication architecture. You certainly don't want to use root. And you want to be really granular and specific and grant only replication slave to the designated object. All right. Once you've created your user, the next thing you do is open up your option file, and you need to enable binary logging. log-bin. Now, whether you specify a custom name and path for that file is up to you. That's optional. binlog do db is also optional. You'd only specify that if you wanted to denote specifically which database you were replicating. Good idea, actually. In this example, we're saying we only want to replicate my_database. This third line is definitely required. You're going to need to specify a unique server ID both for the master server and the slave server. In this case, this server is designated server ID 1. save the option file, close it, then you would bounce MySQLD. This, of course, is the Unix Linux syntax. In Windows, we would net stop MySQL, net start MySQL. The other side of the equation, of course, is the slave server, and on this guy, we're simply opening up our option file and setting a couple required parameters and optionally setting a bunch of others. Of course, the required parameters are, as I said earlier, we need to set a mandatory server ID that's unique. In this case, this slave server is server ID 2. Another required parameter is master host. This will denote the IP address of, you guessed it, the master server. We also need to, and we want to be careful with our file system security, remember, our master user and master password. This is the credentialing that's going to allow the slave server to log on to the master server and retrieve those updates from the binary log. Replicate do DB, you know what that means now. This is saying replicate only the following database. There's some additional stuff here that you see. We need to save the file, bounce the server. There's some additional stuff that you see here, including bouncing the server and some command line stuff that I'm going to demonstrate in the upcoming demo. I'll reserve those further actions for that time. Speaking of demo, it's time for us to get into that demo and configure replication. The setup, to give you the schema for the demo, our master server is going to be our Linux machine, LinNugget, and our slave in this case is going to be our Windows machine, WinNugget. And what I've done is I've removed the world database from WinNugget, so world does not exist on that machine anymore. Of course, it does on LinNugget, so we've got world. And so the goal of our scenario in this lab is to begin a one-way replication process such that at the end of this lab, we're replicating the world database in toto such that any changes, any modifications that we make to world on LinNugget will immediately be propagated on WinNugget. Let's get started. I'll show you how easy it is to get the ball rolling. Here we are on LinNugget 1. I'm going to show you how to configure replication. First thing we're going to want to do is set up our master server, which, as previously noted, is the present box. I'm going to start off by opening up our my.cnf option file in my favorite text editor, Pico. What I'm going to do is scroll down into the MySQLD portion of the file. And as you know, we need to enable binary logging. I'm not going to specify a custom name or path for the file. I'm just going to enable logging in general. I'm going to specify the optional parameter binlog do DB to inform MySQL server that I only want to replicate the world sample database. And finally, I'm going to put the required parameters server ID in here, and I'm identifying LinNugget 1 as server ID 1. I'll now do a Control-O to write out the file, Control-X to leave, and I'll now restart the MySQLD service, which on Linux is, I'll do a sudo etc init.d MySQL restart. Next, we're going to log into the MySQL server proper. We have to create our slave user. I'm going to log in as root, and instead of grant user and grant privilege, as you see here, I'm going to just do a one-line command here, where I'm saying grant replication slave on ***. Of course, this is a lab environment here, so I'm not all that worried about security. I'm saying granted on all objects to, and I'm creating a new user called slave_user, and I'm using % here to denote from any host in a production environment. As I said earlier, you'll want to constrain this to a particular box, identified by, and then I'm providing a specific password. Now to verify that this user is created, I'll select I'll select user, host, password from mysql.user, and we can see slave_user from any host, and then of course our hashed password. Alright, now it's time to prepare the database for export from the master to the slave. So what I'll do is use the world database, and I'm going to issue a command flush tables. What I should do, just to be safe, is flush my privileges. You'll remember we learned about this command earlier in the course. I created the user just to flush privileges to reload all my grant tables. And now what I'm going to do is run flush tables with read lock. Now that's going to be important to run to make sure that I prevent anybody from writing to the world database and give me kind of exclusive control over world temporarily while I prepare it for export. I'm about ready to take a backup of world and then shuttle it on over, shuttle a copy of it, I should say, over to my slave database. So flush tables with read lock, and then this is an important step. I'm going to run show master status. And what this is going to do is show the file name for my current binary log. You know, the binary log exists in my data dir. It shows me my current position, what's called my offset. These are important values. I'm going to need to make a note of these because I'm going to need these values, the file name as well as the position offset, when I set up the slave momentarily, because once the slave starts processing updates, it's going to need to know where to pick up. In other words, where to start processing those updates from. In other words, where it's going to leave off from, where it's going to resume from in the binary log on the master. We know that the binlog doDB is the replicated database. There's also another optional parameter that we're not using. This is an explicit ignore list called binlog ignore. That's blank. We're not dealing with this. Cool. So let's \Q to leave the shell. I'll clear the screen to bring us to the top of the terminal shell. And it's now time for us to get those existing world database tables in our data from the master to the slave. There's a couple ways to do it. Preferred way, actually, is to use the good old MySQL dump command from the command line. And that's simply what I'm going to do right now. We cover MySQL dump in a great deal of detail in the Certified MySQL Associate and the DBA1 CBT Nuggets course. Here I'm just going to simply run the command. It's MySQL dump, and I'm going to authenticate as root, prompt for a password. I'm going to specify the opt switch and say that I want to back up the world database, and we're going to back it up to a .sql script file called world.sql. We're prompted for our root password, which I'll provide, and that's all there is to it. If I ls, we see that in our present working directory, which is my trainer's home folder, I have world.sql. And if I open up world.sql, we see that this is simply a nicely formatted MySQL dump file that gives us all of our environment variables and then the DDL table structure for our three world database files, city, country, and country language. And then after we define those tables, we actually have the data. Before we go over to WinNugget1, our slave machine, and restore this backed up database and complete our configuration, we need to unlock our tables. So let me log back into MySQL, make sure that the world database is fully open for business, and I'll catch you momentarily over on the Windows machine. Alrighty then, we're over on WinNugget1, our slave box, and it's time for us to configure this slave to receive updates from LinNugget1. First thing we'll want to do is log into MySQL over here and create the shell, create the database. Well, first let me just prove to you that we don't have world on this instance of MySQL. So let's create the shell, create database world, just to make sure that we create the receptacle for it. Now we have it. And we'll quit out. We need to bring in the data from the world database that we backed up on the master and apply it now to the slave. Let's do that now. Good deal. Next, we'll open up our my.ini option file, navigate down to MySQLD, and we'll add some configuration parameters. We'll recall that LinNugget1 has an IP address of 10.0.0.1 and that the server ID for LinNugget1 is 1. Therefore, we'll create a server ID of 2 for WinNugget1. The master host value for LinNugget is its IP, so it's 10.0.0.1. The master user value, we'll recall, was slave_user. The master password value was password. We'll throw in master connect retry. of 60, and we'll do a replicate DODB of world. Let's bounce the MySQL service. And finally, we have some MySQL client specific parameters to set. These command line parameters, as you see, are in large part repeats of what you saw in the option file. Change master to master host, there's the IP address. Master user equals slave user, master password equals password. Basically, the deal here is we're passing in live values. In particular, the most important ones are master log file and master log position. This is where earlier when we ran show master status on the master server, I mentioned that it was important for you to write down the binary log file name and that position offset value, because we're passing those in live as parameters. And I'm passing in specifically 1, 2, 3, 4, 5. Make sure you get that number of zeros correct and the offset value. So let me submit this batch. I must have had a syntax error here somewhere. Awfully easy to do. I can see the error right off the bat. I put in, instead of an equal sign, a dash. So let me correct that text. All right, think we're good to go here. Still another error. This operation cannot be performed when a running slave runs stop slave first. Again, this is a very educational moment. The command I missed here is slave stop. The slave is currently running. Try it one more time with feeling. I'm using the up arrow, as I'm sure you know by now. I'll come back to my first command, change master to master host, pressed enter, give myself another line, feed in these line by line by line, master log file, log position. Finally, I'm able to submit that batch. Looks like we're good to go. Now that I've passed that configuration in, I can start up the slave with start slave. No errors, no warnings. So now, whenever my world database is updated on the master, all changes will be replicated on the slave. So you know what we need to do. We need to go back to LinNugget, make an update, and then come back to WinNugget and verify that those replications have in fact taken place. So let's complete our demonstration. Back on LinNugget now, we'll log into MySQL, use world, run a simple select against city to see what we have here, and then let's run a simple update just to change some data and make sure that that update has been propagated to our slave MySQL server. All right, so I'm changing the country code column to SYR, where the country code is AFG. Just a very trivial change here. And of course, it's gone into effect and changed 4 rows, the first 4 rows of the table. No problem. So therefore, if I quit out here, I'll clear the screen. To complete this process, let's connect now from the master to the slave. We don't have to actually physically connect on WinNugget. I've created a user on WinNugget that allows us to connect remotely, so we'll simply do this. We'll use the -H connection and specify we want to connect to WinNugget 1. We'll select current _ user. We see we're connecting root at LinNugget 1. I'll run status. We used all these commands so far. Again, this is a nice capstone from stuff we've learned earlier. You see our connection is to WinNugget via TCP/IP. And finally, I'll run select star from world.city limit 5. And sure enough, you can see now that we are on WinNugget now. We're on the slave machine. And our first 4 rows are reflecting the update that we recently enacted on LinNugget. Therefore, our replication architecture is working exactly as it should. In this nugget, we looked at 2 very useful elements for scaling out MySQL. The first was, how do we install multiple instances of MySQL Server on the same piece of hardware? The second was, how do we bring MySQL database data closer to our users, both from within a local area network as well as potentially over slow wide area networking links? So that's the end of the course. I'm confident now that after having studied this entire Nugget series, you're ready to go out and tackle the MySQL DBA2 exam. It's been a pleasure working with you, and I wish you all the best in your professional work as MySQL DBAs. I hope that this has been informative for you, and I'd like to thank you for viewing.